So I had some goals for today. One of them was to make databases sexy and cool, but that's not going to happen. But I thought maybe we could, for us developers, that we could maybe start thinking about putting a database into our code earlier on in the process, and I'm hopefully this will show you something that's pretty easy to do. If you scan this with your phone, this will take you to some of the how-tos. It's not directly; it'll give you a link, but you probably want to email that to yourself so you can open up the Google Drive that has this stuff there. It's got the LabVIEW code that I'm using. I'm just going to show you a subset of it, but it'll have all the LabVIEW code and it'll have setup instructions, which I'll go through a bit here, and you'll see that's pretty simple. So,
in which case do we need no SQL?
In which that's up to you. So, do we need? Do you want I would say the question was, when do you need SQL or not? No SQL. It just gives you another option. So, the good, bad, and the scalable. The story behind this is when I first heard about MongoDB. That was the way that it was described. They reminded me of a movie that I saw years ago. So I looked some of that up and looked up the character and watched the movie. I thought there was some funny parts in it that I could incorporate into the show or into the presentation. That didn't go quite as planned, but we'll try. So the movie actually is pretty infamous. You might want to watch it at home in a dark room or something. So Mongo is a database that is fast. That's one of the selling points of it. It's something fast. And how fast is it? A fast reference from the movie. It's also a database that's easy to use. It is so easy that we got a little delay. See for the movie. There's a quick implementation is another selling point of Mongo. And if you know the movie, this is the scene that I wanted to play. I'm glad I'm not the oldest one in here, or so old that I'm the only one who knows about this. But I'm not going. This one, I could do it, but it is quick to implement. And then, how about a database that's easy to scale? And that's also true of Mongo. And once again, another scene of the movie that really watch this on your own time. But one of the biggest selling points for this, for the customer that I'm going to speak of, was that it was free. For small developments, you can get all the tools you can get a lot of the tools for free. Some of them I had to create. And that's why I'm doing this presentation. Not everything is free. So for most of us, this is going to be free. It's going to be free software for our development, at least to get started. And back to the Mongo character. This is the scene that finally that brought to mind when I first started working on Mongo.
Hey, you can't park that animal over there. It's illegal.
That's Alex Karras from I think he played for maybe the Detroit Lions, but he became an actor. So it's a database that's fast, easy to use, quick implementation, and easy to scale. And in most cases, it'll be free. So a little history. It was developed in 2009 to address some of the limitations of relational databases. And I put down there at the bottom this is where the actual name comes from, is from the word humongous. It's the scalability with replication and sharding. Replication is being able to copy to multiple places. Sharding, splitting up large documents so that they can be easily read. And the schema, this is probably for us, or for me, is probably the biggest selling point, besides being free, is that you don't have to have any specific schema for using MongoDB. And hopefully I demonstrate this, that it's easy to build and modify. So this is in the document of the directory that you, or on the Google Drive that you just linked to. So this is the server. That's where you find the server. And this is the MongoDB Compass. This is a GUI that you can use to access the database. And you can put it on any computer, and you can theoretically look at any database on any other computer. And I'm going to try to do that now. We have a server down here that I'll be using later on. And if you're going to use an external computers to access the server, you're going to need to poke a hole in the firewall. So the Mongo uses what they call documents, and they're JSON documents that have been converted to binary. It's more efficient, but it's not as easily as programmable. We have to use some DLLs that I'll show you in a minute that will convert the JSON text to BSON. Server data is organized by the database name, and you know, when I was looking at this project, I was thinking maybe the database name would be the name of a product, like widget 1, widget 2, you know, whatever made sense in that project. And then below that would be collections. So you can have collections of, and I thought maybe those would be serial numbers, but it's like it's kind of like a directory structure in a file system where you have, you know, higher level database collection, and then down below you'd have individual documents. That would be the individual test data. And what's really cool, which I mentioned before, there is no real fixed and set schema. So this individual test data can be anything. Anything that you can put into a document can be saved underneath this one collection. And another thing that I put into the code was there's a unique document ID that's usually given to the document from the server, but if you can sneak it in there sneak in your own ID into the document before you upload it to the server, it'll use that one. You can use that to maybe name the type of the test. So the end of this part is that there's a lot of different ways of organizing your data, and in the end, the end data, the documents can all be different types. In this case, the customer had 26 different tests, and so that presented a problem, but it informed him on which direction we wanted to go when we were selecting a database. And it's small scale, low traffic, and they weren't sure if they wanted SQL. So we, so it turned out that Mongo is the perfect choice, and that's where we went.
Well, it depends what kind of queries that you want to write.
Yeah. So, so like I mentioned, there's two DLLs. There's tons of methods in these DLLs. I only touched on a fraction of them. So somebody who has the time and energy could really dig in there and really open this up to LabVIEW. The MongoDB driver, that's responsible for connecting to the server and scanning for different records, uploading records, deleting them, and
Where do records come into this picture? The lowest in the hierarchy is a document.
it is a document.
The records.
Yeah, he wanted to know where do the records come in this whole thing. So the records are documents, right? So BSON documents are the records. So you'll have, if you could look in the digital realm with your eyes, like in the Matrix, you could see the BSON document as a JSON document. And each of those elements in the JSON document gets put into the server underneath the same document. And so you can access each one of those individual elements in the document. And maybe this might be a good thing for us to see towards the end of this presentation. The second DLL that we're going to work on, or that I worked on, was the BSON document, BSON DLL. And what that does is that creates these BSON documents for you. It converts the different types of data types into a label and then a value, and does this in BSON. And changes the data types and then creates the documents, and then the DLL, the driver DLL will insert that into the database. So my struggle at first was 26 different data sets. How do you get those? The database has no problem with 26 different ones, but LabVIEW, we might have a lot of different, it might struggle with different types. So what I did here, and this is, I used a VIM with a cluster in, and coming out was an array of variants. And that's how, that was my implementation. All right. So what I've done is I've followed the instructions that I gave you, and I set up a Mongo server on this computer, and I want to kind of go through the back, through the block diagram here, and show you how kind of simple that this software really is. There's three parts to connecting to a database. You have your connection string, which we see up here, which is pretty much an IP address. The database name, great. The database name and the collection name. And the nice thing about Mongo is if you don't provide those things, it'll create those for you. So if you wanted to start a new database, you can do that just by uploading a document with those connections to the server. And the second part of it is building your BSON document. Here I'm putting a timestamp on it. I'm converting to an array of variants. But then from that array of variants, I convert to the BSON elements, then to the document, and then I insert it into the array. So that's really all that's there. And if you look inside some of these, there's fancy wrappers on very little code.
And that document contains what data?
Oh, so for instance, The way I did it is it's all in clusters, whatever you want to put in this cluster here. You could have different clusters. I gave two simple examples. This one has a couple of min current, a max current. This other one has a waveform, an array. And they both use the same code. You just plug them in and upload it. And hopefully this will work. So, question.
Are you going to publish this as a package?
Maybe. Is it? If people convince me to, it's a lot of work. But yeah, I've got it. If you follow the link, it's there. But yeah, I could do that. Yes.
Oh, I guess it's already shared.
I'm sharing it, so you guys can go there and mess with it. It's.
So if you run a bunch of tests, say in a single test on a bunch of UUTs, right? Each one of those, the results of each test for each unit will go into a separate document, right?
Yes.
And then you typically would want to run some sort of statistics across documents, right?
Yeah.
But maybe we'll want to find, particular, say the test can have waveforms, right, as you put it. Then you may want to find whatever record, basically, timestamp and whatever parameter that you're measuring, right? Whatever limits for that or whatever, when whatever value was reached, for example. How does this facilitate it versus SQL? You would have it in a set, for each timestamp, you would have a separate record, right? Here you have them all in one document for the entire test.
You have them in different documents in one folder. You can have them in different documents in one folder.
Different points, time points in the stamp?
Yeah.
In the test?
Well,
It doesn't make
no, it would be this is the complete data. This waveform analysis
Yes,
example.
that's what we said. So you put the entire waveform, for example, you run a test for an hour, and every minute you measure whatever voltage, right?
Yeah.
So that creates your waveform, right? Then you put that all that data in a single document within the realm of this database. What kind of queries can be run against that if you have everything?
So
You can be measuring multiple parameters, of course, at different moments of time. You want to do some statistics, right? Plus, this is just one test for one unit, but you want to run statistics across multiple UUTs. I don't know, pass-fail ratio, for example.
So you would do a query of whatever the serial number of whatever the unit is, and you'd get the waveform from this specific type of file, and you could download a whole bunch of those, and you'd do that in LabVIEW, of course. You'd do your statistical analysis that way.
We actually selected Mongo as the underpinning system link server. So if you're familiar with system link server, it uses Mongo under the hood. And I wasn't too close to it, but I know there was a lot of analysis around it is a tool chain for waveform data in particular. You get irregular links, you got all these things that are uniquely challenging around retrieval of waveform data. And for a combination of performance and scale, and also I remember how it dealt with arrays of data. We deemed it to be more efficient for the sake of large engineering data. And that's why we chose it. To this day, it's what underpins system link server.
So if the data is table-like, you would put that entire table into a document in the context of this.
I don't quite know how we implemented it. I just know that however we did it, for reasons he probably better understands, it was like there's so many irregularities that you don't have a nice clean table of data typically.
Of course,
yeah.
So,
And that's actually one of the strengths of a NoSQL database, because philosophically, if you are sticking it into a SQL database, you need to fit the form that you've predefined, the table structure and whatever. And with a NoSQL database, you just throw data at it, and you organize it when you query it, essentially. So it's perfect for advanced queries, AI type applications, anything where you're going to look at the data differently later on than where you were looking at it when you created it.
Does the lack of structure prevent you from?
The lack of structure is openness and reconfigurability forever, as opposed to being stuck in.
As long as you know how it's structured, all of the different data sets are structured differently. As long as you know how they're structured, you can query them because you know what the structure is. So you can create the query any way you want.
It's also really super good at doing things like looking for similar data sets where there are voids in one data set and not in another.
If you could start over.
Yeah.
So what was the question?
How storing unstructured data is better than storing than structured.
Right. Like, what's the difference between storing it structured in SQL or storing it in Mongo or some other NoSQL where there isn't the same level of structure? And the answer is there's a lot of the real world that does really good with the no structure because the world isn't as structured as a SQL database is. So in general, we're finding more and more ways for NoSQL to apply to real world conditions. Like one example would be if you're running a bunch of tests on data sets that are similar, but like some ways you run the test, it doesn't gather results for certain parts of the test. It just leaves them out. In a NoSQL sense, you don't have to do anything special with that. That data is just not there when you go to query it. As opposed to, do you have empty tables, or are you filling in something, or do you make a table that is populated like with a subtable with tags that allow you to make instances of table data because you want to use a different number in one place versus another. NoSQL, you throw the data in there. It's not larger than it needs to be. It doesn't have any structure that it doesn't need to have until you go to query it when you kind of look for that structure.
Query, whatever engine that performs the queries
That's where
has to be
all the
much-
work is.
Much smarter.
Yeah. So and the other way to look at it too, in a SQL database, the overhead CPU usage happens front end when you're pushing the data in, and then it's organized. With a NoSQL database, you just throw the data in there, and the time penalty is on the back end when you go to query it. But there are methods for making that more efficient, clustering and those sorts of things as well. But that's my 2 cents.
Oh, thanks, Greg. That was a mistake. I'm unable to communicate over the network. I have a server local on this computer, and that's working. And this is going to show you probably some of the questions that you just brought up. These are these type defs here, these clusters. You know, I'm writing them, but I'm also reading them. So I know what my data is going to look like when I read this type of data. And so what I did, I can run this thing, run it. It's written to the written to the server. You can see that here under what did we call it? We called it the database is widget 1. Well, hopefully, I gotta reload the data. So we have this widget 1 data now. It created the database because it wasn't already there. It created the collection because it wasn't already there. And here you can see I hit it a couple times, and I can change the data. And I can change that to a pass, and well, that's probably good. And run this again. Kind of hard to work on this. Collect the data. Reload data. Did I not hit?
I think you ran.
Did I not run it?
I think you missed run.
Oh, I'm clicking too quickly. Oh, there we go. Okay. All right, and it puts in another record. Now, we can see that
Are you using a serializer or
serializer.
like for the data structure, you just casting variants to a string? Or?
So I know got the variant, so I know what data type it is coming in, and then I equate that to whatever data type Mongo wants to see. Like Boolean's not a problem, strings not a problem. Some of the other things will take a little bit of work. You're going to have to figure out how to manipulate different things into different arrays, right? That's going to be kind of difficult. But there's pretty much a one-to-one between a lot of the different data types from here to there. So the variant comes in, you know what data type it is. Okay, I need a Boolean. I got a Boolean here. I need a Boolean in my MongoDB. And now what's the value of it? And what's the label name for that value? I know those from the variant too. And I just plug those into the DLL. That creates my little BSON little segment for the BSON document. And if we look here, if we look, we got here are the different element. So here's the little elements in the records. And I've got a different data type here. I've got this other one, and this one, I just want to run this one to show that you can have different types of data within the same collection. Come on. And you can see that we have, this one has array data, and this one has whatever, some kind of limits test that we put in there. So reading, this is like getting the toothpaste back in the tube. And but you have a key, and that is your type def. So when I'm reading, and in the way I implemented it was the type def name is in the ID of the document. So when I do a query and I get a document from the Mongo database, I'll scan that first element and see, okay, this is the type def that I need to use. And now I can look at those different data types, and I can plug them back into the type def. So here's somewhere. Oh, there it is. And oops, I'm gonna have to change it to local. Hold on, because we're at now local. The query looks like this. You have your connection string. So you're telling the software what server you want to connect to. This is the local host. This one's on this computer, and if I had the network figured out, it could be on that computer or one at home or wherever. And now, but I'm going to look for something in the database named widget on this computer with a collection name of 1, 2, 3, 4. But I'm going to search for the operator Craig. It doesn't know what that. In this search, it's just going to grab the first one that has Craig as the operator, and it's going to bring that BSON document back and display it as JSON. And from the JSON, I'll be able to parse that back into the type def. Oh, you do whatever you. Yeah. Oh.
So you have a bunch of tests for a bunch of units run by different operators. Will you bring up all the tests, all the documents for a particular operator name?
Yes. So it will do that. Not in this one, but you would have to do a multi-query. This is just a single. We'll just return the first response. But you can make this. It doesn't have to be operator. It could be date or ID or some other kind of way of searching for your records, and that makes it smart. So if I click, once again, pretty simple in the background. We're just going to make a network connection. We're gonna create a query. I'm gonna look for Craig as the operator. It's gonna bring back, in this case, it's a single query. It's gonna bring back one. I display the, I think I display the JSON when I'm done, and then I parse all the, figure out here's where I figure out what kind of type def it is. based off of the very first document ID. And then this VI will convert all those elements back into the type def using this reference to that type def. So if I click this, we can see that took the very first one. You know, we got waveform analysis. It's got the name, and works like it should. And if I change this to Tony, it switches to the other type def and picks out the first one. You can see the query on the JSON type of document down below as the query result. And that's it. That's what I have. You can mess around with the software if you want. I'd like to start with the Santa Claus part of the demonstration now. Are there any
How would you run a query? For example, you have current, right, waveforms in each document recorded during the tests. Say I want to know average current value across all those tests halfway through the test. How would you run a query like that?
So I would make it a multi-query, and I would say let's say min current, which isn't a very good one, but you put min current in here, and leave the element value open, I guess. No, yeah, maybe I don't know that one. I might not know that answer.
Currently, you have as a query result, you have a document in terms of this database.
Yeah.
First document found out of all that database has that has operator as Craig.
Craig or Tony, yeah.
Okay.
So, like I've said, this is kind of a basic introduction to this, and as far as the methods and that are available on those DLLs that I showed you, there were thousands of them, and a lot of it was a lot of sleuthing, going to GitHub and finding documentation on what these things do, and then trial and error and trying to get them to work, and using the Mongo compass to see whether I was actually using it correctly or not. So, any more questions, I should say?